Hello. Now we are going to look at the mean of our datasets in some detail. So the mean, we're going to start off with a bunch of discussion of language. So the mean of our dataset is sometimes called X with a little bar on top of it, with a little line on top of it, and sometimes it might even be called mu. So this is a Greek letter and it is just a normal letter U with a little tail coming out the front. And those are the different symbols we might see every once in a while for the mean. And the mean just means the original average that we would have known about, or where we add up the number of numbers, where we add up our numbers and then divide by the number of numbers. Now, in terms of the language we can come across, to add stuff up, so to add numbers, we know can be called the sum of numbers, and we'll often see this in the context of the mean. So the sum of the numbers, as opposed to saying we add up the numbers, means the same thing, but you'll often come across the word sum. And as an aside, sum in maths has a symbol, just like mean has a symbol, and it's the capital letter sigma, and it means to add stuff up. So if we see capital letter sigma, something that a little bit looks like a capital letter E, but kind of with a V shape in the middle as opposed to an arm in the middle, that is going to mean to add everything up. So if we ever see that symbol, that means we're going to add up all of the stuff that it tells us to add up. So this is our symbol for sum of things, or to add things up. So we can add up our numbers and divide by the number of numbers. Now, a way of phrasing this that can be helpful for more complicated questions is to think about the implication of this in terms of the total. If we add up all of the numbers in our dataset, or sum up all the numbers in our dataset, that means we get the total value of all of the numbers in our dataset. We get the total value of our dataset. And then we're dividing by the number of numbers. Well, that's the total number of terms. So we have the total value of all of our numbers added up together, divided by the total number of terms in our dataset. And this idea of thinking in terms of totals can be very useful for harder questions. So this definition is perfectly correct. This can be more useful for phrasing it to get us into the right headspace for what we do for harder questions. Now let's get into some examples. The money 5 students have with them in euro is €5, €8, €2, €7, and €8. So our data is not arranged from smallest to biggest in this case. If we were dealing with mode or median, that would be our first step, write everything from smallest to biggest. For mean, we don't really need to. The mean amount of money per student is what we're asked for. So I'm going to use the language we have for this. This is going to be X bar, and this is going to be the sum of all of our numbers divided by the number of numbers. So we just add up all of our numbers, plus 2, plus 7, plus 8, all divided by our number of numbers, which is 1, 2, 3, 4, 5. So we add up all of our numbers and we get 30 divided by 5, which gives us 6. Now the fact that 6 is not a number in our data set is not a problem. That just means it is the average amount of money that the students have on them. It doesn't mean that any individual student must have that amount of money on them. One quick point on our list here, we can see that most of the students have roughly the same amount of money, give or take, but the 2 is quite far out of the rest of the group, and we would call numbers that are quite far out of the main data set, of the main group, outliers or extreme values. Extreme. So any number or where we have a bunch of data that's fairly close together, the numbers are fairly close together, they won't be the same, but fairly close together, and then we have 1 or 2 that are very, very far outside of the main group, we would call them outliers, or sometimes we would call them extreme values. So we can come across that language. Do we see any outliers in this data set? Do we see any extreme values in this data set? And in this case, the 2 would be a bit of an outlier. It's quite a bit lower than the rest of them. Now, here's a slightly more advanced example where this way of thinking about mean can be helpful. The mean of 6 numbers is 4. When a number is added, the mean becomes 5. Find the number that was added. So if we think in terms of totals, how did we get the mean of 6 numbers? Well, we added up all of our numbers and we got a total. We got the sum of all of our numbers, and that was divided by, so this is the total value of all of our numbers, and that was divided by 6, which was the total number of terms, the total number of numbers. And that ended up being equal to 4. Now this is a straightforward enough equation. I know that I could just multiply both sides by 6. And the total that I started with must be equal to 24. So I don't know what the numbers were that I added together, but I do know that their total was 24. And then I'm told that when I add a number to this, when I add a number to this total, then the mean becomes 5. So what do we got? The total that we originally had plus some number, which I'll call x, divided by how many numbers this time? That's going to be 7 numbers. We added an extra number, so the total number of numbers is now 7, and that mean was 5. So by thinking in terms of totals, we're able to work out what we're talking about. And now we have another equation that we can solve. We know that original total was 24 plus x all over 7 is equal to 5. Rearrange to find x, our number that was added on to our original total to make our new mean of 5. So 7 divided by 7 is 1. We're left with 24 plus x is equal to 35. Subtract 24 from both sides. We get x is equal to 11. So that was the number that was added on. So even though we never knew anything about the original, not that we never knew anything, no, we didn't know anything about the specific numbers in our original group that gave us a mean of 4, we were still able to figure out this number that got added on by thinking in terms of the totals. And this is quite a powerful tool for when we have more advanced mean questions. Now here we have a data set, but we're missing one of the numbers in our data set, and we're told that this overall data set has a mean of 3. So can we find the value of x? Well, I know that the mean is where I add up all my numbers, plus x plus 2 plus 8, and divide by my number of numbers. That's 1, 2, 3, 4, 5, 6. And that's equal to 3. So that's the sum of my numbers divided by the number of numbers. And the fact that there's an x in there doesn't change anything about that. So I'm going to add up my like terms. And when I do, I get 14. So I have 14 plus x all over 6 is equal to 3. And now I'm going to rearrange in order to get the x by itself. So I have 14 plus x is equal to 18. Subtract 14 from both sides in order to get the x by itself. I end up with x is equal to 4. And if I was unsure of whether my answer had worked out, I could sub that in and show that I got a mean of 3. So if I added up all of my numbers with x being 4 divided by 6, do I get the number 3? And that allows me to quickly check whether I made a mistake. So that is what we need for the mean.